Here we have the basic hydraulics review. This will be reviewing how to do friction loss calculations. This is the short version. The long version does a better job of explaining the why so that you have a good understanding of that. You should have a good understanding of that. If you don't have a good understanding of that, you might want to take a look at the longer version. If you do have a very good understanding of it and you just need a quick refresher, that's what this is looking for. So it's still pertinent, some of the pieces here. Why do we do hydraulics? Well, you got to figure out your pump discharge pressure so you know how much pressure is needed to pump your hose lay. But just as important, you need to know what equipment can pump the hose lay. Hence, we look at pump performance and we merge that with pump discharge pressure to get us something functional. And then we take that information and use that to evaluate the hose lay for troubleshooting purposes. Why is it not working the way I want? So objective wise, this is really for the full course, not necessarily for what we're doing here. And our main piece here, objective wise, will be to refresh you on how to do hydraulics equations. To do this, you are going to need to know what nozzle pressure you want to be using. You need to know what head pressure you are going to have. You're going to be able to know, or you're going to need to know the volume you're flowing in each piece of the hose, and from that you can extrapolate friction loss. This is a diagram of a hose lay. You should be familiar with this already, but just to make sure everybody's on the same page, this is a pump. This is showing my elevation right here. Okay, so it's raising 100 feet. This is a piece of 1.5 inch hose, right? Because it says it's 500 feet of 1.5 inch hose. Out here on the end, I have laterals. They're 100 feet of inch because typically that's what they are. I have nozzles out at the end. They are noted as a 3/16 tip. Okay, so that's a tip. They are noted as 20 gallons a minute. That means it's a barrel nozzle. Volume given means barrel nozzle. And this one just says 3/8, which means 3/8 tip. I write these things on the side of the truck. So the hydraulics formula, simplified version. I have nozzle pressure plus or minus head pressure plus friction loss. That equals my pump discharge pressure. So what is nozzle pressure? Well, for the sake of the equation, nozzle pressure is either 50 or 100. 50 for tips, 100 for barrel nozzles. Head pressure. Head pressure is your elevation. So for head pressure, you take your elevation change total and you divide it by 2. That gives you the pressure. If it's downhill, it's a negative. It's subtracted from your total pump pressure needs. If it is uphill, it is added to your total pump pressure needs. There you go. There's an example. Going downhill 100 feet, you divide by 2, you get 50. So you're gaining 50 because it's downhill. Friction loss. Friction loss is a function of volume, length of hose lay, and the diameter of the hose. Those are the things you need to know. It is completely independent of head pressure. You need to use the friction loss calculator to get your friction loss. So when you're looking at your diagram gives you some of this information that you need, like hose diameter and the lengths of hose, and then you note the water flowing on your diagram as you calculate it. How do you determine the volume that you're flowing? It's by the tips or the nozzles. So on a barrel nozzle, we give you the volume because that's how they work. Nozzle pressure is 100. Your volume is given in the problem that you're working out. So if you look here, the barrel nozzle in this equation says 20 gallons a minute. You know you're flowing 20 gallons a minute. When you're doing tips, like Forester nozzles, you'll have to calculate the volume flown using the nozzle discharge calculator, which is the top portion of your friction loss calculator, and you can follow the directions on that, or the longer version gives a detailed descriptor of how to do so. You take that friction loss, you multiply it by the number of lengths of hose that you have in that section of your hose lay. And remember that we round to whole numbers in general, almost entirely when doing friction loss. Add all of those things up together, you get pump discharge pressure, which is the total amount of pressure needed to pump the hose lay. And then you take that number and you can compare it to pump performances to determine whether or not your pump can pump that hose lay. Problem number 1, take a look at that one. I would recommend working it out and then watching the rest of this as to how we come up with the answers. Problem number 1, in our example here, I need a better black pen. I always write my equation up. NP plus or minus HP plus FL, so nozzle pressure, head pressure, friction loss. I always write that up. If I write that up there, it gives me a good anchor point to start from. Okay, and that's going to equal PDP. Okay, it looks like my pen started working. And I start here. What's my nozzle pressure? And if I'm looking at this equation, I say quarter inch. Quarter inch means tips. And tips are, there's only 2 possible answers here. It's either 50 or 100. Tips are 50, right? All right, next one, head pressure. HP, head pressure. So it looks like I go up 160 feet. Half of my elevation change is my pressure. That's the key, super simple way to put it. Half the elevation. So 160 feet, half of that is 80. Half of that's 80. So I have a head pressure of plus, because I'm going up, plus 80. A little plus there, you can just erase your minus, whatever works for you. We're going to do friction loss. I forgot where we were, so we're going to do friction loss. The first thing to do with friction loss is I have to identify where my water's flowing. So it's about flow, volume. All right, I have quarter-inch tips. I have several. I have 4 quarter-inch tips. What does a quarter-inch tip flow for volume? At 50 psi, because that's the nozzle pressure we want for a tip, is 50 psi. What does a quarter-inch tip produce? 13 gallons per minute. So I'm just going to write that up here. Wow. GPM, there we go. 13 GPM. Okay, I use blue just because it makes it easier for everyone else to see, I hope. So that's what each one of those tips is flowing. Now I come out to the end of my map, end of my hose lay, and I say how much water is flowing through this piece of 1-inch hose. Well, 13 gallons a minute is flowing through that piece of 1-inch hose, because that's what that tip needs to keep going. That's what that tip is leaking out. 13 to the outside. So the 1-inch hose has 13 gallons per minute. And as I follow my hose lay back, now I'm in a piece of 1.5 inch. And how much volume is in that? 13. 13 gallons a minute has to flow out here. Okay, now I come back another. I'm in this piece of 1.5 inch. Why am I not doing this? Well, because in friction loss, we only have to calculate for one. We'll get into that part in a minute. But I'm following my flow. So we can look at this and we can say there's 13 gallons per minute up here. And up here, in this piece of hose, what do I have? I have 13 and 13, so 26. All right, so 26 gallons a minute are flowing through this piece of 1.5 inch, 13 comes out here, and 13 keeps going and out the end. All right,
So if I look at this next lat, it's again going to be 13. Just like the tip, because it's feeding the tip. All right, I come back to this piece of inch on. All right, I'm looking at this piece of 1.5 hose. How much volume is flowing through this piece of 1.5 hose? It's 39. So 39 gallons per minute flows through this piece of 1.5 hose. 13 comes off and 26 keeps going. 13 comes off and 13 keeps going. All right, last lat, also 13 gallons per minute. So as I back up, this piece of the 600-foot chunk of hose, how much volume is flowing through that? Well, I have 39 and I have 13, so 52. So I'm saying I have 52 gallons per minute flowing through this 600-foot chunk of hose up to the first lat, and then 13 comes off, 39 gallons a minute keeps flowing out, and then 13 comes off, and 26 gallons per minute continues to flow down my hose lay. 13 comes out, and 13 gallons per minute continues to flow out to the end of my hose lay. Okay, that's how I track my volume. Tracking your volume is the first step in doing friction loss. So then we go to friction loss. And I like to start at the end and work my way back. The same way I tracked my volume. Start with the smaller numbers, work my way back up to the bigger numbers. All right, I write this all down on my my map, my diagram here. You can all. So I have 1-inch hose, 13 gallons a minute is 4 PSI friction loss. So I wrote FL4. All right. Okay, so friction loss. We're moving back down here to the next piece of hose. It's different than the first. So the next piece of hose is 1.5 inches at 13 gallons per minute. So we put 13 gallons per minute in for flow on our friction loss calculator. We look at the 1.5 inch mark, and it's like a half. It's actually 0.6. It's just a smidge over half. And we round to the nearest whole number. So we're going to call it 1. Okay. Friction loss of 1. We'll address what happens when it's closer to 0 later. Friction loss of 1. So, move it back one more. I'm looking at 26 gallons a minute through 1.5 inch hose. 26 gallons per minute through 1.5 inch hose. Put 26 gallons per minute in my friction loss calculator and read my 1.5 inch mark, and it says 2. Remember, we are rounding to the nearest whole number. All right, I keep coming back. Now I have 1.5 inch hose with 39 gallons per minute flowing through it. So I put my friction loss calculator on 39 gallons per minute, and I read my 1.5 inch mark, and I get 5. Rounding to the nearest whole number, I get 5. All right, keep coming back. Now I have 52 gallons per minute flowing through 1.5 inch hose. So I put my friction loss calculator on 52 gallons per minute, and I read my 1.5 inch hose mark, and I get 9. So friction loss of 9. But I got more than one chunk of hose. So it's 9 per 100. 100, there are 600 feet, which means I have 6 lengths of hose. So at 9 per length of hose, I get 9 times 6, 54. Or 54 PSI of friction loss in this chunk of the hose lay. All right, to come up with this number here in my main equation, I simply add all of these together. So 54 plus 5 is 59. 61, 62, 66. Right? Yeah. That's 66 psi of friction loss for the whole thing. And then I add it all together, and I'm looking at 196.
Yes.
Here, switch colors. Not in friction loss anymore. I mean answers. Answers are green. 196. Correct? At 52 gallons per minute. It's important to put the 52 gallons per minute. It gives me a lot more information. Not required for the pre-work, but if you do it, good on you, because you're on the right track. We'll get into why we do that here in a second.
And then I take the answer that I had for my problem, and I do pump performance, and I take a look at a pump performance chart. That pump performance chart gives you the abilities of your pump. So free flow is 0 pressure, maximum volume. I see it's not listed there for the Mark III because it's the same as at 50. It's 89. And then for every pressure that it can produce, it gives you that rundown of what volume is available at a given pressure. So if I need 200 psi, I can still build 52 gallons per minute. In problem number 1, we had 196 psi at 52 gallons per minute. And looking at this chart, 52 gallons per minute, 200 psi still available. So we're right in there. Our Mark III pump could do it as long as it's a good pump and at sea level, and which it's probably not, but it should be pretty close, and certainly worth a try. Another way to look at pump performance where you can extrapolate a little bit more information is if you graph that out. Also, pump performance for at least for Mark III is listed in your IRPGs, and that can be a useful place since it's usually in your pocket. Here's problem number 2. Take a look at problem number 2, see if you can work that out, and then you can check your answers against the product that we...
And recording. All right, so here we have problem number 2. Problem number 2, we have a pump. Pump pumps up 190 feet, down 70 feet, and then over to our actual hose lay where we're fighting fire. There are 4 3/16 tips in this problem, in this hose lay. So the first thing I do is I write up my equation up here so I have something to work off of. That's always my first step. And I go to my equation, and number 1 is nozzle pressure. So I look at the nozzles. Nozzle pressure is always one of 2 answers, 50 or 100. And if I have 3/16 tips, forgot my inches mark, 3/16 tips, it's going to be either 50 or 100, and it'd be 50. Tips are always 50. So nozzle pressure is 50. And recording. All right, head pressure. So in this case, I go up 190 feet, but then I come down 70 feet. Okay? So my total head pressure needs to pump this hose lay, I'm gaining this 70 over here, I'm losing that 190. I can subtract my 70 off my 190, I get 120. 120 feet of total elevation change in this theoretical closed system. So I'm looking at 120 feet. If I'm looking at 120 feet, that's half my elevation for my head pressure. So I have 60 PSI for head pressure. And it is a plus. I am still going uphill more than I am going downhill. All right, now we are looking at friction loss. All right, so here's our friction loss. You'll notice I grabbed the blue pen. because the first step in friction loss is volume. If I take my 3/16 tip and I put it in my nozzle discharge calculator on the top of my friction loss calculator, and I put that over to 50 because that's the nozzle pressure we run for a tip, and I read where it says 3/16, I get a little over 7. But we rounded the whole number, generally. So we're going to go 7 GPM. All right? And they're all 7 GPM. So every nozzle is moving 7 gallons per minute. Now I start tracing my water back. All right, I'm out here at the end. I have 1-inch hose, and how much water do I have flowing through that? I have 7 gallons per minute. Okay, and then in this next piece, which is 1.5-inch hose, I also have 7 gallons per minute. That 7 gallons per minute flows through this hose and out that lat. Next piece of 1.5-inch hose, I have 2 lats that it's feeding. So that'd be 14 gallons per minute. All right, and 14 gallons per minute flows through this hose, 7 comes out, 7 keeps going out to the end. All right, so I back it up one more time, and the next piece of 1.5-inch hose has 21 gallons per minute. Okay, and the next piece of 1.5-inch hose, which is the 2,000 foot mark here, has 1 more lat that it's feeding, so I'm looking at 28 gallons per minute. So we'll just do a quick follow on where the water's flowing. I have 28 gallons per minute flowing out of my pump, up and over to this mountaintop, and down, and then out here, and then 7 gallons per minute comes off, and 21 gallons per minute keeps flowing. 7 gallons a minute comes off, and 14 gallons a minute keeps flowing. 7 gallons a minute comes off, and another 7 gallon a minute keeps flowing, and out to the last nozzle. That's what my water's doing. And from there, I can calculate friction loss. All right, well, I didn't write 7 gallons a minute on all these lats like I did on the first one. Yeah, I wrote it up here, and it's somewhat implied. And I only do friction loss for 1 lat. So I only have to calculate it for 1. Why? Well, the easy answer is it's a rule. That's the easiest answer, and if you need an easy answer, there you go. It's a rule. You only do it for 1 lat, the biggest one. Whatever the biggest friction loss is going to be. If you had different sizes, it'd be the biggest one. Okay. The complicated answer is that we think of a hose lay as a pressurized vessel, and pressure is equal in all directions, even though in reality, anyway, pressure is equal in all directions. And so if I overcome enough friction loss to deal with this lateral, I will have overcome the friction loss needs for the rest of the laterals. They are effectively in parallel. That's the complicated answer. Easy answer, it's a rule, 1 lat. Let's talk friction loss. All right, friction loss in this one, I'm gonna document it just slightly different, give you a different approach. This is really handy for a lot of people. And I'm gonna go friction loss 1, and then ultimately I'll do more than just 1. But I don't know how many yet, so we'll get there.
You're on.
We're on. All right, so friction loss. I wrote the friction loss 1, friction loss 2. We'll add to that as we go. It's just a different way to keep track of this. It's gonna be really helpful for some people. But I still write it out here. And one reason I still write it out here is because at some point when I'm trying to troubleshoot my system, if I know where certain things lay on my map or my diagram, it'll help me out. So let's do friction loss. I come out here to my end, because I always start out here at the end, and I have a piece of 1-inch hose, one piece of 1-inch hose with 7 gallons a minute in there. I put 7 gallons a minute into the friction loss calculator. That's the bottom portion of my slide rule calculator. And I look at 1-inch hose, and it shows about 1. Okay, so my friction loss is 1. So my friction loss is 1. All right, and then I come back Now I'm looking at 1.5 hose, 7 gallons a minute. I don't even have to move my friction loss calculator. It's already on 7 gallons a minute, right? Okay, now that you got it back there after you straightened it out. 1.5 hose, well, shoot, where is it? It's low on my friction loss calculator. It's less than 1, right? This is one of those things, it's like, well, how much difference does it make if I put a 1 in here or if I put a 0? Both of those answers can be correct. The real answer is that I have less than 1 psi of friction loss. There is less than 1 psi of friction loss in this piece of hose. You can totally say I have 0 because plus or minus 1 psi isn't going to make a difference, and we already know that it's going to be less than 1. It'll be like plus or minus a half a psi. So it could be 1 or it could be 0, it doesn't matter. A lot of people like to err on the side of caution and make sure they have enough pressure, and they like to put 1 in there. I like to strive for accuracy, and I say when I'm looking at this, it's irrelevant, it's 0. Well, we're going to call the friction loss 1 on this piece. And I put FL of 1 up here. You know, the reality is it's very insignificant friction loss in an 1.5 hose moving that low of volume. And over a 100-foot chunk, it's insignificant in the overall equation. If it's less than 1 psi of friction loss over, say, 2,000 feet, me saying 0 is probably not accurate because there is some friction loss in there. And it's going to add up, and I'm going to have to overcome it. But me saying 1 probably isn't accurate either, because I'm overestimating my friction loss needs over this huge, long chunk of hose lay. So just be aware of that when you get into these really long hose lays and you come up to the point where you're looking at 0-ish or 1-ish of friction loss. That's where you may actually start splitting it. But generally, we're going to go to the whole number. Go to the whole number, keep it simple. In this case, we're going to use 1, it rounds to 1. All right, so I look at my next piece of hose. I just bring her on back because I don't have to deal with these lats. 14 gallons a minute through 1.5 hose. I put 14 in the bottom of my friction loss calculator, and I look at my 1.5, and it should say 1. Pretty close to 1. Up here, I'll make myself another little spot for friction loss. And it's another 1. All right, I bring her back another notch. Now I'm looking at 21 gallons a minute through 1.5 hose, and I plug that into my friction loss, 21 gallons a minute on that little arrow on the top of the bottom portion. And I look at 1.5 hose, and it should tell me about 2. All right, and I come back again, and I'm looking through at 28 gallons per minute through 1.5 hose. I put 28 gallons per minute in my friction loss calculator, and I read the 1.5 hose, and I should get 3. I'm looking at friction loss of 3 per 100 because that's a long chunk, like 2,000 feet long. All right, and then I go 3 times the number of lengths of hose I have in it. So 2,000 feet takes 20 lengths of hose, so that's 3 times 20. My friction loss is 60. All right, come up here, FL5 is going to be 60. I now have some answers. Now I have some stuff to work with. So let's see, I got, if I add all of this together, I get 50 plus 60 is 110, 11, 12, 13, 14, 15, so 175. Green pen. 28 gallons per minute. And that's the end.
And that concludes our short version. If you need more assistance or you don't understand why something's working, take a look at the longer version with more detailed information.